Yeah.
So good day, everyone. We are the next reporter, and our topic is the Centroid of Moment Tensor project. Next. So we are the reporters, Faith Santillana, and the second reporter will be Antoinette Jean Parillo. So for introduction, Centroid Moment Tensor refers to the fact that the estimates provide spatial and temporal average of the earthquake's distribution of seismic moment. So this is a project that specifies or traces the seismic moment of our earthquake. Next, please. So let's talk all about this project. So this project was founded by Adam Dziwonski. It is founded at Harvard University and operated there as the Harvard CMT project from 1982 to 2006. It is led first by Professor Dziwonski and later by Professor Ekstrom. So this project was founded by a professor, and it takes how many years before proving this project? So from 1982 to 2006, and afterwards, since it is a long period of time, it is then nasundan ng isa pang professor yung research na study na ito, or na project na ito. Next, please. So the centroid moment tensor, or CMT, is a reliable method for calculating moment tensors by which the global centroid moment tensor project systematically studies global seismicity starting from the 80s. So it is one of the most reliable, or isa sa pinaka-inaasahang method for calculating moment tensors ng ating earthquake. So it might be useful, or naging useful siya sa atin in terms of calculating our earthquake on how ano ba, gaano kalakas or gaano kahina yung magnitude. So it helps us to prepare and be alert in such ways. So this project started in mid-80s. Next, please. Adam and Freeman developed a technique for determining earthquake source mechanisms using model sums. They applied this to all earthquakes above 5.5 magnitudes and created the CMT, or the Centroid Moment Tensor catalog. This seismological compendium is widely used, providing earthquake mechanisms, seismotectonics, and scaling laws to thousands of scientists worldwide. So, etong technique na na-develop nilang dalawa is naging useful not just in their times, but I think it is still useful until now. And we are using this method as of present, I think. And also, it is only applicable to earthquakes that is, or that has 5.5 magnitudes. Next, please. So GCMT's primary goals are determination of moment tensors for major earthquakes globally and quick dissemination of results. Excuse me. So its primary goal, or yung pinaka-point talaga kung bakit nila or bakit sila nag-research ng such project, is because they want to create, or they want to have this very useful method that we can use to measure earthquakes, especially dun sa mga places na malapit sa epicenter, which is marami din naman sa atin here in the Philippines. So, in order to give informations, or in order to disseminate informations, before or after an earthquake. This is a very useful determination method that is used not just in their place but also globally. Ibig sabihin na adopted din natin itong ganitong method. Next, please. So for over 40 years, the Global Centroid Moment Tensor project has determined location and source parameters for global recorded earthquakes larger than magnitude 5.0. So sabi nga kanina, 'di ba? The only magnitude that can possibly be applicable na magamit yung method na sinabi is those that has a 5 larger than 5.0 magnitude. So in over 40 years, ibig sabihin napaka tagal na ginagamit, which states the fact na nagiging useful yung ginawa nila or it is reliable. Next, please. Real-time centroid moment tensor determination for large earthquakes from local and regional displacement records. Real-time centroid moment, ibig sabihin during that time or kung ano mismo yung nangyari during an earthquake or such happenings is nare-record yun. The having na yung ginagamit nila is centroid moment tensor determination. So that is what they use to determine larger magnitude of earthquakes. Next, please. The seismic moment tensor is a crucial modeling tool for earthquakes, providing information on event size, fault plane geometry, and faulting style. It is useful for tectonic studies, stress regime, determination, earthquake response, tsunami early warning, and finite fault source modeling across various earthquake magnitudes. So this seismic moment tensor is one of the crucial modeling tool for earthquakes. Also, this one is a part of their project, providing information on event size. So since we are talking about earthquakes, those information is all related to earthquakes. For example, is as said in the PowerPoint presentation is the event size o kung gaano kalaki yung naapektuhan ng ating earthquake, the fault plane, geometry, and the faulting system kung saan nagsimula yung fault ng earthquake, and also the style since we have a lot of style. It is useful for tectonic studies, stress, determination, earthquake response, tsunami, early warning. So it can be useful also if early determination ng ating earth we can have early warnings to tsunami, earthquake response, and also we do have aftershocks. So we can be or we can provide a much fast na tulong sa isang specific na place na mayroong earthquake na nangyari. So, next please. The Global Centroid Moment Tensor project is the most comprehensive catalog of earthquake empty solutions focusing on teleseismic data collection and catalog compilation. Real-time MTs can be obtained for small to medium events using time domain waveform matching inversion schemes, but real-time CMT determination for medium to large events remains an active research. So the real-time one is for small to medium events. So, ibig sabihin, hindi ganun kalakasan na yung earthquake. But the CMT or yung centroidal naman is used for determining the medium to large events or yung medyo mas malakas na earthquake happenings. Now, the global naman is it focuses most commonly to teleseismic data collection and catalog compilation ng earthquake. Next, please.
Okay, good day everyone. I'm the second reporter and I will explain the example na research namin about determining, I mean using the CMT. So first, the 2010 MW 7.2 El Mayor Cocapa earthquake in northern Baja California, Mexico caused a complex rupture, possibly involving normal and right lateral faulting. The rupture plane showed warp faults and a bilateral rake. So, in 2010, there's a major earthquake which is 7.2 magnitude in El Mayor Cocapa. So, isa ni siya sa example nga gikandak which is nga gigamitan og CMT para ma-determine kung unsa ka kusog ang iyahang magnitude og unsa pud ka dako ang kumbaga nga kanang dako gud nga impact niya sa katong gikuhanan sa linog. Then next is so as you can see mo na yung graph nga ang kaning graph kay mo na siya ang nakapaloob sa katong example sa kaning 7.2 nga linog. So diya sa graph mo na siya ang 300 seconds of displacement records at 50 of the 105 CRTN stations that exceeded the 15 millimeters threshold with a 120 seconds moving average filter applied for the 2010 MW 7.2 El Mayor Cocapan earthquake. So, kaning graph kay kapalob diri ang record nga. So, sa kaning graph kay mas nag-exceed pagod siya sa katong time nga 120 seconds. So, mo ning gipakita diri sa graph nga ingani good kung paano ginagamit tong CMT. So like it states here that the seismic velocity model used in the inversion is obtained from a simplification of the California Community Velocity Model version 4. So ang structure jud sa kaning zone is highly heterogeneous. So ang ato ang model is average sa grid nga sa corners. So then next is ang kaning second na picture. So then sa kaning graph, so nagipakita po diri ang summary of the inversion results for the El Mayor Cocapa earthquake. So the top 3 panels are the centroid determination as a function of a time compared to the location reported by USGS W-phase algorithm and the global centroid moment tensor project. So the fourth panel is the computed magnitude and the fifth panel, the misfit as defined in equation 10. So kaning nga graph kay mo ni siya ang summary sa inversion nga results para sa El Mayor Ucapa earthquake. So katong kaning makita nato nga graph nga top 3 pero kadua pa lang man ni kay mo ni siya ang katong isa gyapon sa ginagamit para ma-determine pod using CMT kung sa kakusog ang linog. So next is kanina pod nga graph. So as you can see sa kanina graph kay ipakita po diri akong ang snapshots of the inversion results for the El Mayor Cocapa earthquake comparing the USGS WPACE result with the GPS real-time inversion. So, sa kanina graph kay dalawa ni siya murag gi-compare gud siya sa GPS using GPS og CMT. Then also shown in is the comparison between the observed and model horizontal offsets. Then the red dots indicate the nodes used for the grid search. Dark gray dots are 1 year of aftershocks reported by the Southern California Seismic Network, and black lines indicate quaternary faults in Southern California. So, ang kaning mga red dots nga makita nato diri pero ano mo gud siya naka black and white ang picture. So, Moto siya ang mga siya ginagamit para sa mga grid search. To, ang kaning dark gray pod nga dots, kay mo na siya tong 1 year nga aftershocks nga na batian gud nila for 1 year nga dito gikan sa Southern California. So, ang kanang black lines pod kay mo po na siya ga-indicate sa quaternary faults in Southern California. So, kumbaga quarterly lang na siya na mga faults nga nakita nila using CMT o GPS. So, mo to ang kaibahan dira sa red dots, sa dark gray dots o sa black lines. So, ingana sila ka-useful kay since mas ma-determine pa sa katong mga researchers or kumbaga katong mga gakandak sa kaninga project kung makita nila tong 'di ba maglinog so ma-determine dayon niya magbantay-bantay kay nay aftershock so ma-determine niya na tong mga aftershock so kaya at the end of the day makabalo sila kung pila ka aftershocks ang nag-occur sa kana nga place. Then next is kaning nga graph. So kaning nga graph is a geometrical parameters of the best double couple solution extracted from the moment tensor inversion and compared to the USGS W phase post-process result for the 2010 El Mayor copper earthquake. So data for both nodal planes NP1 and NP2 are plotted at 3 seconds intervals for clarity. So it's defined in equation 9. So data start at 41 seconds when enough stations detect an offset as described in section 3. So, ang kaninga graph kay mo na siya ang geometrical parameters of the best double couple. So the focal mechanism displays some interesting characteristic during the inversion. So it shows the snapshots of the inversion and centered location at 50 seconds intervals. So by 120 seconds, ang best double couple solution kay almost pure na jud siya nga mo strike sleep with strike and deep similar to the W phase solution and the centroid 30 kilometers gikan sa W phase centroid. So then mo to siya. Then next for the final rapid CMT solution. So diri the final CMT solution is quickly obtained after the end of the rupture process as soon as the full permanent deformation has been discerned. So, the convergence to the final CMT solution is illustrated in figure 9 for both earthquakes. So, ang CMT, so sa kaning final nga CMT solution kay madali lang siya ma-obtain after sa human sa rupture process. As soon as ang deformation kay visible na gud siya kana makita na nimo. So, ma-recognize ang kaning final rapid solution. So, mas ma-determine pa nila ang kinalabasan gud sa kaning gibuhat nila nga project which is kaning CMT. So, after sa katong rupture process, kumbaga katong mga ano gud mga resulta sa katong linog sa aftershock something ana then labi na katong nakita na nila ang full deformation jud then mo ni siya so diri siya makita ang katong kwan ang final nga sa SMT then so ang kaning sa picture kay kaning dalawa so muna siya ang detailed comparison between the fast CMT and GCMT results for the Tokachi-Oki event. So, comparison between the best double couple solutions as computed in A and B are the synthetic and observed displacement of A. So, So ang kani siya nga picture nga ipangita diri og kaning mo ni siya ang detail nga comparison siya between sa katong past nga CMT event report og global CMT report. So as you can see dira sa graph, so ay sa picture nga nakita diri ang moment tensor kung sa katong kakusgan. So ang katong best double couple pod og inversion summary. So diri makita tanan ang ang comparison nila. So gi-compare silang dalawa sa kuan. So kani diri kay mao po na siya kani siya nga ano kay parang siya sa Tokachi Oki event. So ang Tokachi Oki event, so another po ni siya nga major earthquake nga nag-occur po sa ano, wait lang, sa Japan. So kusog po di siya nga linog. I think 8 point something ata ni siya. So ano siya, 8.3 magnitude. So kusog jud siya, mas kusog pa siya sa katong ito is tong example na to karon. So ang kanina pod siya kay mao na po siya ang detailed nga comparison between sa fast CMT og W phase results for the LMA or Kappa event. So which katong gi-discuss na ko. Then comparison between the best couple solutions as computed in A and B and a synthetic and observed displacement of A. So diri ang purpose ani kay para makita ang comparison. So unsa ang i-compare sila kung saan para ma-determine ang best nga double couple solutions as computed daw sa A o B. Then, that's all. Thank you. Wait lang. So, ang babalik ko,